Hey guys, Troy Winchester here from Davis Technical College. Today we want to talk about setting offsets on the Haas VF2. Okay guys, today we're going to talk about setting offsets on the VF2. You should have already watched a video using the tool presetter, so we're not going to cover that right now, but what we are going to cover is you've just come from the tool presetter. You have a list of your tools that you're going to use for whatever the application is. In this case, I've picked two tools. I've picked a 1/4 inch 2-flute end mill, and it looks like probably a 5/8 3-flute end mill. We're just going to call those tool 1 and tool 2. I'll just leave those right there on the machine. So you've got that information already. You've measured the tool. The tool measurement now needs to be input into the machine. We're going to look at the screen here for a second. We've powered the machine up. After you've powered the machine up, you're going to push this offset button right here. The offset button, as you can see, will toggle between the tool offset and the fixture offset, or the work offset. So right now, we're going to push the button again and go to tool offset. We're going to cursor up, and we're going to go ahead, and it's usually best to clear out these values because you don't know what the previous tool was before. So we want to cursor over to the geometry column in the tool offset. And the easiest way to clear that out is just to hit 0 and F1. Arrow straight down, 0, F1, down, 0, F1. 0, F1, and last one, 0, F1. So we've just cleared those out, okay? We now want to enter that number for the two tools that we have measured. We've got tool 1, so we're going to cursor back up in the geometry column, tool 1. That number is entered as a negative value, so we're going to type it in as negative 3.2939, enter, okay? We'll cursor down to the second tool. The second tool is a little bit longer, negative 4.5281. That number's right down here in the lower left-hand corner of your screen. Okay, so we have now taken tool 1, which is our short little end mill, and if you're curious, you could actually measure this distance from basically there to the tip of that tool. Should measure roughly 3.2. It measured exactly that, but as far as your measuring ability, it's going to be pretty dang close. This is tool 2. It's 4.5. You can see the difference between tool 1 and tool 2. All right. So we've entered those two tools. If you had a project that needed more tools, you would measure all 5 or 6 tools and enter that in the screen. Okay. So we're done with this part of the process right now. Let's go down. Let's push the offset button now. And now we're down here in your fixture offset. Your fixture offset is your way of telling the machine where part 0 is. It's actually the distance from machine 0 to part 0, okay? So a lot of people will just use G54. That's a very common number, so we're going to 0 that out. We're going to 0 out all 3 numbers. So we're going to set G54 on our machine right here, okay? The next thing we need to do is we're just going to call up our edge finder. So I have looked ahead of time and found that tool 6 is an edge finder. So I'm just going to come over here and go to MDI, and I'm going to say T6 ATC. Better shut the door on this machine. ATC forward. And tool 6 is called up, okay? We still want to be in our offset screen. And we're on this line right here. We're going to position our cursor over here to the x-axis. It doesn't really matter which one you do first, but I like to do x, then y, then z. I'm going to turn around here. Okay, we're not going to actually edge find it, but we're going to run through the process. So what we would do is we would put our machine in handle, jog, and we're going to select our x-axis, and we're going to select a feed rate of about 10 thousandths per click. And you can see that that's going to move x. X is pretty close right now, so I'm going to go ahead and shift to the y-axis. And I'm going to bring Z down a little bit so that I can see. Now, what I'm going to do is I'm going to move X and Y into their simulated position. I'm not going to actually use the edge finder and make it jump or break. I'm just going to move it to the location to show you guys how to do this. That looks pretty good in the x-axis. That looks pretty good in the y-axis. So we're going to assume that I have properly used my edge finder and picked up that edge. Hang on where there we go. Okay, so the edge finder is now in location. I am in my G54. Okay. I want to come over here and I want to find the button that says Part 0 Set. If I push Part 0 Set, it takes the actual location of my machine, which is from home position, 15 inches, 990 thousandths, and stores that in my offset page. It's automatically moved to the y-axis, so I'm going to go ahead and push the Part 0 Set again, and it will take my 5.61 location from home position and store that in there. Now, we're not going to do Z just yet. Keep in mind, guys, you're using an edge finder. The edge finder has a 200 thousandths diameter tip. We need to offset our current setting by that 100 thousandths. So I've cursored back to my x-axis. To make this work, I know that I need to move the x-axis positive 100 thousandths. So I'm going to make sure it's highlighted on X, and I'm just going to say 0.1. That's down here in the input. Now, the beauty of the machine is if I use the enter button, it will add that value directly to my offset. So we were 15.990. I hit enter. It's now 15.890. It's closer to home position by 100 thousandths. And we'll do the same thing in Y. Now, a lot of times when you're in the Y-axis, you have to make sure you go the right direction. That's true in both axes, but if we were picking up the part and moving towards us, Y negative, then we would enter a Y negative value. If we were moving towards the hard jaw of the vise, then we would move a positive amount. Since I'm just simulating it here, it really doesn't matter. I'm going to pretend that I'm coming off the part. So I'm going to add a negative 0.1, enter, and this number, which is negative 5.6, will actually increase by 100 thousandths. So now the tool is theoretically right over the corner of that x0, y0. Okay, and we're actually done with the x and y component of G54. The last thing that we have to do, guys, is we have to now tell the machine where Z surface is, the top of the part. Okay, and an easy way to remember that is the machine would really like to know where the face of the spindle is in relation to the top of the part. And that was the hard thing for me to figure out when I first started learning positive offsets. The face of the spindle to the top of the part is what the machine really wants to know. Well, that's very difficult to set. But if you use the tool in the machine, that makes it a lot easier. So I'm going to go ahead and shut the door, and I'm going to do a zero return Z single axis. I'm going to get rid of the tool chain, or the edge finder, excuse me. One of the easiest ways to load your tools in the machine is to follow these steps right here. So I sent the machine home. I want to put tool 1 in the machine, okay? So I come over here to MDI, and I push T1, and I do an ATC forward. Okay? Now, I've already removed tool 1 from the machine, but if there was a tool in there that you didn't want, you would just open the door, make sure you're in the handle mode, and you could take that tool out. The tool right now is out of the machine, so we don't have to show that. I now have tool 1 in my hand. On the Haas machines, guys, it doesn't really matter which way you put it in, but let's do it right from the beginning. There is a double cutout on your tool, okay? On the newer VF2, the one that I'm on right now, the tool, the double cutout should go to the right, the 3 o'clock position. If you're on our older machine, the VF2, then the double cutout should be at the 6 o'clock position. So we're on the newer machine, so the double cutout in the spindle oriented position is at the 3 o'clock position. I'm going to reach in there. Okay. As you put the tool in the machine, there's a little bit of air pressure. You have to overcome that just a little bit. Align the tool and release the button. Do not let go of the tool until you're sure that the tool is securely tied into the spindle. So now we've got tool 1 in the machine. Tool 1 had a length of 3 inches, 293 9/10 thousandths. Okay? We're going to go to handle. We're going to jog Z down. Now, I'm going to show a tool that you may not have seen used before. This particular tool is a touch-off tool. It is exactly 2 inches long. Okay? It is not magnetic, it's just electronic. When the tool touches this top sensor, one of these little LED lights will pop on. And I may even turn the lights off in the control if they don't show up well enough for you guys to see. So we're going to bring this down. Move this over so the tool is directly under the sensor is directly under the tool. Whoops. It's amazing how tricky it is to get it centered until you get the tool closer to the part. There we go. Okay. Turn one of those forward. And now, we're going to put the machine in 1 thou increments. We're going to come down. Now this tool is spring loaded. So if you actually touch that little probe, it will compress. So there's no fear of damaging your tool. If you're using the 1, 2, 3 block method, we're always moving up, trying to slide the block underneath it. We'll help you with the difference between those two, and maybe we'll just get some more of these so that everybody has the ability to use them. Because this does speed things up a little bit. Okay, so I'm in handle jog, I'm in Z. Yep, I'm moving down. Okay, so we move down. Okay. My batteries must be getting weak. Okay, as I bring it down right there, the light clicks on. Okay. So now I know that that tool is exactly 2 inches above the part. So we go back to our control. We go to offset. We cursor over to Z-axis. Now, we want to record where the machine is at this time. So again, we're going to use our part 0 set, and our machine has moved down roughly 9-inch 747 thousandths. So I press that button, boom, right there. Now, because I'm using that tool, I need to add that value to this offset. Because it's already a negative value, I'm going to enter that number as an additional negative value. So we're going to come over here and we're going to say negative 3.2939. Okay? 3.2939, double check yourself. I'm on, whoops, get over here on Z column. Okay. And then I'm going to hit enter. Okay. That changed the offset to negative 13.04. Then the next thing I have to do is I have to add whatever your touch-off block is. In this case, because I'm using my 2-inch touch probe, I will add a negative . Okay, that made my overall offset negative 15.040. Okay. Now we can go ahead. We're going to shut the door. We're going to send it home. All right. One thing to remember, guys, is the reason we're doing this, positive offset, gives us the ability to use any measured tool. Okay? It doesn't matter what the tool is. As long as that tool has been measured using the tool presetter, installed in the machine, we can use any tool we want. We don't have to, it speeds up production, it makes it a lot easier. The biggest difference is now, if we're working on a part that's 3 inches above the vise, or a part that's completely flush with the vise, or maybe a part that's clamped to the table. It doesn't matter what the tool length is. The offset in your G54 needs to be set with one tool to the part, and then all of the other tools will work. Now, one thing I'm going to do really quick is I'm going to show you how to test this offset. All right, guys, just to recap what we're covering in this video. We've showed you how to install a tool in the machine. We've showed you that you need to go to the tool measuring device and measure that tool, record all the measurements of the tools that you're going to use. Go ahead and load all of the tools in the machine. Input your tool values in the control in the proper offset, whether that be one tool or 10 tools. Go ahead and input that information. Come over to the machine and set your X and Y axis in your G54 or 55, 56. It doesn't matter which offset you use, and a lot of times it's a good idea for you to use a different offset than somebody else. So don't get in the habit of staying with G54 only. You can use any of these offsets, G54 through 59, that's not a problem. So set your offset, and then go ahead and set your Z offset using the process we showed you. Touch off on your probe, whatever that block is. Record your part 0. Add the tool length to that offset and add whatever your block is. So you've got a combination of 3 numbers that you've added together to get your overall G54Z value, okay? Again, guys, if you have any questions about how to do any of this, please see your instructor. Watch this video a time or two if you need to, and then let's go out on the machine and let you set it up, and then we will show you how to verify that. Again, guys, thanks for your attention, and see your instructors if you have any questions. Thank you.